So we started today with just a little bit of review. These are critical first 20 topics. 3 plus and minus 6 root 2 all over 6. Sorry, it's messy. I'm going to fix that. And the next one was x squared plus 9x plus 8. And the last one was x squared minus 3x equals 1. Okay, so I'm going to show you all of these answers, and then I want an honest opinion about how many of you knew how to do it. Now, I'm going to process this for a second to make sure I did it right. You know how I'm checking? I'm going 3 times 1 makes 3. 3 times the 2 makes 6 root 2's. And then, of course, 3 times 2 makes 6. And so then my 3's can cancel. Let's talk about why you couldn't just cancel this 3 and this 6 right off the bat. A lot of kids think in problems like this, they're like, but there's one on the top, there's one on the bottom. The teacher told me I could cancel. No. Look at this. Would you agree that's 5/4? And if I cancel those, is it still 5/4? No. You can't cancel when they're being added like that. See, this is being added and subtracted. It cannot be just canceled. Now, if, however, it had been a multiply problem, 1 times 4 over 4, that's 4 over 4, which is equal to 1, and then it could be canceled. So you can cancel them if it's a multiply problem. So see how I made it into a multiply problem? By factoring out the 3. Then it's a multiply problem, and this is a multiply problem, and then these can be canceled. Final answer, I know it looks funny, is 1 plus and minus 2 root 2 all over 2. How many of you had that right? Honest answers. Thank you very much. Like 4 of you knew that. Okay, and now that I showed you, though, I'm going to give you another one in a minute to practice that with. All right, on this one, it should have been easy as pie. You're supposed to be able to factor. So easy, it's like, oh, yeah, I know this. That's easy. And then how do I make an 8? Probably an 8 and a 1. Could have been a 4 and a 2, but I check like this, and I go, oh, I guess it's right, because I got 8x and 1x, and that makes 9x, and that's what I wanted. There, it's factored. Now, some kids make the mistake of stopping there, but you were supposed to solve it. So then the answers were -8 and -1. How many of you had that right? Honesty. Really important to have honesty. All right, good. Some of you had it part right. Maybe you just factored it, didn't know you were supposed to go further. All right. Next up. Yes, question about that.
Why can't it be just plus 8 and plus 1?
Okay, so I get, you're asking, why aren't the answers just 8 and 1? Well, what they do is stick the answers back in, and that's how you can tell if you did it right. Does this, when I stick 8 in, does it actually equal 0?
No.
No. If I stuck -8 in, would it actually equal 0?
I didn't get that.
Apparently, he didn't either. Siri doesn't even get it. Okay, so if I put -8 in, yeah, it equals 0. See? That's why it needs to be -8. And this needs to be -1. Okay? It's because you're trying to make the equation equal 0. All right, last but not least, we have this guy. And you should have subtracted 1 from both sides. So it was x squared minus 3x minus 1 equals 0. And it does not factor, no matter how long you play with it and rearrange the x's and the numbers and the plus and the minus, it will not factor. So what do? X equals negative plus or minus the of b squared all over 2a. Very good. So negative b, in this case, that's negative of -3 plus or minus the square root of b squared, which is this, which is b squared, which would be 9 minus 4ac. This, from my experience, is where everybody screws up. So I'm going to take a second and write out the a, which is 1, and the c, which is -1. Because, see, then there's 2 negatives here and here. And that's where people mess up if they're gonna. Because all over 2a is really easy. 2 times a, which is 1, is 2. Nobody messes up that. And it's really Well, occasionally there's a kid who screws up and forgets that that's positive 3, but it's always under the root where people mess up. So 9 plus 4. Still some people are going to be like, it says 9 minus 4. There's 2 negatives. 9 plus 4 is 13, all over 2. There is, I understand that she has to go, is your final answer. Okay? I know that's not a super satisfying answer, like the answers are 2 and 3, but these are places, they're just decimals. So if I had to get, the answers are x-intercepts, it's like a weird decimal. It's when it comes out where it's not 1 and it's not, or not -1, it's not -2. It's something like weird in between. It's that. And you could, with a calculator, figure out square root of 13 and add 3 to it and then divide it by 2, and you could find out what those decimals are if you really like decimals better. Okay, so now that I've taught you for about 6 minutes here, we'll see if that's about 2 minutes per problem. Let's see if that was enough instruction that you can get ones 3 out of 3 right this time. One's just like it. I'm going to make, sorry, that should not be a 5. That should be a 4. Simplify that. Number 2 is going to be and number 3 is going to be I'm going to pause for a second while you give those 3 a try. Call this number 1, call this number 2, call this number 3. Pausing. Okay, here we go. I'm going to move this one down.
No, I'm not saying it doesn't matter. Go all over.
So, on this first one, you should have factored out the 4. There was a 4 in both of them. 4 comes out. A lot of people have this problem where they factor out the 4 and they think it just disappears. But there's a 1 left behind. I can prove it to you because if you multiply this out, you need it to be a 4. What are you going to have? 4 times nothing and it will give you 4? No, you need a 1 there. All over 4 times 2 gives you the 8. Those cancel, and there's your answer. Who had that one right? Raise your hand if you did. Awesome, we're up to way more than half the class. Any questions on that? Okay, now number 2. This one is a factorable one. And I get that it's more tricky, but hey, you're in honors. You shouldn't be like, thinking that they're all going to be easy. How can I get a positive here? But there has to be a negative here. Well, you just go through the options. Could they both be pluses? Could this and this both be a plus? No, you'd never have a negative here. Could there be 1 plus and 1 minus? No, this has to be positive at the end. How could a positive number and a negative number make a positive? So that only leaves one choice. What could it be? 2 negatives. There has to be a negative, and the only way to make this positive would be to have 2 negatives. All right, and then last but not least, how do I make a 4? 2 and 2. There you go. Now, how do I know that's right? Because I can multiply it out quick. What's x times x? X squared. What's the outside and the inside? Negative 2x and another negative 2x. And that makes a total of negative 4x. Look at that. And then the lasts make positive 4. So it worked. So there's my factoring, but that's actually not the final answer. The final answer is that x equals 2. And if you write it twice, it's twice as nice. Why should you write it twice? It reminds you that it's a double. And that means that if you look at the x-intercept, how could it be 2 twice? Because it bounced there. It's like a parabola that bounced at 2. So it's x equals 2 and x equals 2. That's a double root. That means it bounced there. Okay? And last but not least is this one. And this one is subtract 5 from both sides. and I got x squared plus 2x minus 5 equals 0. You can play with that all you want. It's not going to factor. So then you go x equals negative 2 plus or minus the square root of 2 squared, which is 4, minus 4ac. I'm going to write the 4ac part out because my experience, that's where the mistakes are made. 4 times a is 1 times c is negative 5 all over 2a, which is just 2. And again, I'd bet you money that if there's any mistakes in here, that would be because people screw up this part. So double check your that part. Negative 2 plus and minus the square root of 4 plus 20 is 24 all over 2. Now, if you had that, much respect. But if you realize that simplifies, mega respect. Who realized the square root of 24 would simplify? Ah, we got like 7 extra smarty pantses. Here's what happens there. You go root 4 and root 6, and that's really 2 root 6. So then it's negative 2 plus and minus 2 root 6 all over 2. And then you could simplify it even more because there's 2's here and here. And so they are called a GCF, and the greatest common factor can factor out. And I factor out a 2, and I get negative 1 plus or minus root 6 all over 2, which then cancels negative 1 plus and minus root 6. Who got that far without me? All right, I'm just taking note of those faces. That is impressive. Okay, good. I probably, if I was in your class, wouldn't have caught that simplified. All right, so there's a good review of what I consider the most important thing in this whole class, which of the basics, which is factoring. You even have a sign for it. If you can't factor, you should. So then what is the rest of today? Well, we have to talk about a few other things. One is domain and range. Here is a parabola. And let's say it's going through the point 2, 1. We have to know a couple things. We have to know, first of all, that was going to be a parabola, which, do you know that that's y equals x squared is a parabola? And then do you know that this one got moved 2 over and 1 up? Please don't talk. That one got moved 2 over and 1 up. So then if it's a parabola that got moved 2 over and 1 up, that was its function. I want you to process that for a second. And then tell me the domain and the range of this. Hint, your answers are things like negative infinity to positive infinity, or 3 to infinity. In parentheses, usually, but not always. All right, I'm going to pause for a second and see if you can answer those. It's been a while, so I'm not even going to torture any kids with, like, how many of you know this, how many of you don't. So this part, try to remember that when you learned this in higher algebra, your teacher probably told you that the stuff in there is kind of the opposite of what you would expect. Do you get that since it's minus 2, negatives are usually to the left on the graph, but actually this graph moves right 2? Do you get what I mean? It's kind of the opposite of what you would expect. And then the stuff on the outside of the function does what you would expect. Plus 1 seems like up 1, and it is. So you can trust the stuff on the outside. You can't trust the stuff on the inside. Again, I would say I look at that and go, that seems like the negatives are over here. It seems like it should have moved left, but it didn't. It moved to the right. All right, so don't trust the inside. You can trust the outside. And one last thing, the horizontal stuff is on the inside. Horizontal inside. Does anybody remember the other counterpart to that? What's on the outside? Vertical on the outside. All right, I know you didn't learn this last year. It was 2 years ago. So I forgive you for forgetting, but you gotta know this. Horizontal stuff's on the inside, vertical stuff's on the outside, and this was called a transformation of the parent function, which was a quadratic. All of those should be like doable for you. All right, then the domain and range. Domain goes this way and this way. If I let this function run, wouldn't it keep going to the left and to the right? Yep. So this domain is from negative infinity to infinity, and some people like to write INF. It's if you're typing in your answer, it's particularly handy because there's no infinity symbol on a keyboard. So I'm okay with INF, or the sideways 8 for infinity symbols. And the range of this is how low and high it goes. One more rule about these things: the smaller number always has to be first. So the two answers for range are, it goes from 1, a lot of people go, but there's a 2 right there. That's the x. The y value was 1. The lowest it goes is 1. To the highest it goes, look, it's going up forever. Infinity. But there's one little critical mistake, and I hinted at it when I was saying the problem. Usually you use parentheses. Where is the one bracket on this whole thing? On the 1, because it touches 1. Can you touch infinity? No. So you use parentheses. I'm going to say that again. When do you use parentheses? When you can't touch the thing. You can't touch infinities. You can never get there. You can't get like, I'm finally made it to infinity. No, it's further. So you can't touch infinity, so use parentheses. If the graph touches something like 1, it does touch 1. It's right there. It's hit at 1. It's got a spot. Then it would be a bracket. Okay, so this is a bracket. Could it ever be a parenthesis on a 1? Yes. We could make a function that is empty on the inside. And that means it gets right to that spot, but then it doesn't touch there. It goes as close as you can to 1, but it doesn't touch 1. And if that were the case, you'd have a parenthesis on the 1. Because it doesn't touch it. It gets infinitely close, but doesn't touch it. So then I'm going to fill this back in, because again, I was just giving you a what if. What if there had been an empty spot there? Then we would have used a parenthesis, but it touches it, so it's a bracket. Now, I did a lot of the heavy lifting there. You should be able to do this next one. It's just something very similar. Do you remember the absolute values shape? It's not a U shape, it's a... Okay, this is the painful part for the Algebra 2 teacher. Yes?
It's like when it hits 0, it's a 90-degree turn.
Okay, yes. Would you agree that this is kind of the shape? Would you agree that that's sort of a letter? Would you agree that's sort of a V shape? All right. So absolute values are V shapes. The one we just did was an x squared. That was a parabola shape, which is kind of like this. Now, I know you don't remember this stuff, but you need to learn it now as if you had never learned it before. All right. So this graph, it's kind of a V shape for your absolute value graph. So what if I did this to it? Where would it move it? Up, down, left, or right? Up, how far?
8.
Up 8. Yep. Okay. If I had put the 8 on the inside, then it would be a horizontal change. But be careful. Which way does this move? If it seems like it should move to the right 8, you're right. It seems like it should be to the right 8. So it's actually left 8. Okay, so this would move left 8, and then what if I put a plus 5 here? Left 8 and... what's this part? Up 5. What's the horizontal? High vo. Horizontal is on the... what's the I? Inside. And vo. Vertical on the outside. Cool. You learned everything you need to know for today. Now, I know that went kind of fast, and there was a lot of stuff. I'll review it with you before we actually get to the worksheet, but that's it. Domain and range, and parent functions and how they move. All right, so if I just give you this graph and I ask, what's its domain and range? Would you agree you need to know this spot? That spot's called the something. You guys know the name of that? Vertex, very good. All right. Now, I know a lot of people are like, it's all this algebra. I don't remember any of this stuff. It's okay if you don't remember any of it, but it's not okay if you still don't remember any of it in a couple weeks. All right, because this is algebra and we're in algebra 2, so we have to build on the algebra knowledge. Be a little bit like taking Spanish 2, having not remembered anything from Spanish 1. That wouldn't work real well. It would go really fast and be really hard to do. So how do you fix this? I'm assigning today a thing called the first 20, which I already gave you as a like, boom, take it, and then see how you did. And I didn't really give you much chance to like improve it. So now I'm going to give it to you again. It's got 10 choices of problems, so you're going to get a different one than last time. 9 out of 10 chance your quiz will be different on every problem. Okay, occasionally you get a repeat of a question, but those 20 things on the first 20 are all these kinds of things. Like, which way did this move? Well, this was a parabola that went, I'm going to say that that's 3 to the right and up 4. So that's 3 comma 4. If that's 3 comma 4, you should be able to write the equation for this parabola. Hint, it's been flipped upside down and moved to the right 3 and up 4. And besides writing the equation, you should be able to tell me the domain and the range. Let's start with the domain and range. Usually they're in parentheses, except maybe one of those will be a bracket. Take a minute, get your best shot on what this graph is. It involves an x squared, but it's been moved to the right 3 and up 4. And then try to get the domain and range and talk to the kid next to you to see if you've learned this well enough. Let's see if you were on track. First off, domain are the x numbers. And how far does it go in the x direction? Remember, this is the x-axis, right? It goes this way and this way. How far will my function go if I let it run free? Negative infinity to infinity. And when you're taking a Schoology quiz, for example, there's no infinity key. Okay, so you have to type that. The range is how low to how high. And this happens all the time that people get the 3 and the 4 confused. For range, which one should you use? The 4. So it goes from 4. And again, I could see this mistake. From 4 to negative infinity. No. Isn't the smaller number always supposed to be first? So negative infinity, and again, if I was typing it on a Schoology quiz, would have to be first. So I'm going to put negative inf to 4. And how do you decide if something has a bracket? Does it touch 4? Does it look like it touched 4? It touched 4. Bracket. Negative infinity to 4. Now this other part is less important today. The domain and range is the big deal. But this other part, I'm hoping I can get you through this. Would you agree that this one got moved to the right and up? And it went right 3 and up 4. How many of you had that one right? Sweet. Now we've actually learned 2 days worth of stuff. The main thing I really had to teach you was this. All right, so let's start your Schoology quiz together. Everybody find the Schoology quiz. It's your homework. And it's on this
Tonight?
domain and range.
I thought you said we had like 3 days to do it.
No, you're confused. There's homework for tonight that's normal.
Oh.
And then there's homework that's not gonna be due until Monday, and that's different. So right now, find the thing called parent functions, domain and range homework. Open that up, it's a Schoology quiz, and it's due tomorrow. The thing that's not due till Monday is the first 20. Okay, so your first question on that. These are not randomized, so you all have the same first question. It's a parabola. What does it ask you about it? Just read me the question.
Determine the equation and the range for the graph shown below.
Okay, so what do you think the equation was? Did they say y equals, by the way, or did they just have it blank?
Yeah.
It says y equals good. Then don't say y equals again in your answer blank. You know what I mean? If it's already there. So then how do you type that into a computer? I know it's x squared, but how do you type that? X, and there's no squared key on your calculator, right? Caret, yes, there. That's y equals x squared. Okay, that's how you'd put in your answer for Schoology. And then, what does it also ask? Just the range, not the domain? All right. You know why I think they didn't do the domain? Because I think that the teacher didn't figure out you could type INF for infinities. So like, how's the kid going to type? Oh, okay. All right. All right. So, well, I wish they would have had the domain also, but apparently just the range. So what is the range on this thing? It's how low to how high. If you're not good at the domain or range yet, maybe you should write that. It's low to high. How low is the lowest, gentlemen? If I have to keep talking to you, it's not going to work. How low is the lowest that this thing goes? 0. What's the highest that this thing goes? Infinity. And 0 has a bracket on it, and infinity has a parenthesis on it. Yep. I don't see how else you'd tell it, because there's no infinity key, so you have to type INF. Yes?
Why is there a bracket in front of it?
Okay, so does this touch 0 on your picture? I know my picture's not perfect, but it's supposed to be touching 0, right? So when it touches something, there's a bracket on it. Okay, so this function does touch 0. So there's a bracket there. And pro tip on infinities, they always have parentheses because you can't get to infinity. Okay, so again, if we had a graph that went down and had like an empty spot at the bottom of it, we're not going to do that today because it's the first day of this, but then it would mean that it doesn't touch that spot because there's an empty circle there that implies that it gets right to it but doesn't touch it. But for most of the time, I hate words like that, but most of the time, when you have a number, it has a bracket on it because most of the time your graph just touches that number. But that's not really what it is. Some kids think, oh, it's a number, so it has a bracket. No, it's because it touches that spot. That's why it has a bracket. Okay, let's do number 2. Could you please help me out? What's number 2? Is it another picture?
It's a table.
Okay. Could you read me the X's and the Y's and just start with just reading me the X's that are in the table?
0, 1, 2. 9.
Okay. And the Y's? What?
Or, well, 0,
The
1,
2 for
blank.
under the X is blank, and then
Yeah.
there's a 9. So there's 0, 1, blank, 9.
0, 1, blank, 9. Thank you. Okay. And then on the Y's?
0, 1, 2, blank.
Blank. All right. So we got to figure out this spot, and we got to figure out this spot. Now, it must tell you something else. Does it tell you anything else? Oh, it tells you the equation. Read me the equation. Y equals the square root of x. Okay. So they're saying if you put in 0 in this equation, you get 0. And that makes sense to me. If you put in 1 in this equation, right there, you get square root of 1, which is 1. And then they change it up by going, well, what should you put in? So the answer would be 2. So what would you put in right here? What do you think? 4. Good. And on the other way around, if you put in an x is 9.
3.
Yes. There you go. Okay. So keep working on this, and then I know some of you are going to finish this early. Wait, please, just wait. And then there's another little quiz, and it is the Schoology quiz that isn't due until Monday. But that Schoology quiz is called the First 20. You already did it once in class to see where you were on the way in the door. Now we're seeing if you've gotten any better at your algebra basics. I am totally okay with you working on this. It's formative. So like if you want to go watch a video, that would not be cheating. That would be just helping yourself to understand it. Okay, so we gotta make progress on those basics. If you're not making progress on the basics and you got a bad score on your first test, you do have to start questioning, maybe this class is gonna be too hard. All right, that's all I got for you for today.